Games are different from animation and other media in that they're interactive. People are immersed in the story of a game and expect to be able to participate in it and in their world. One of the ways we'll really encourage that interaction in a game is through the use of physics. The Unity editor actually has two different physics systems in it, one for 2D and one for 3D. Right now these game objects are exactly static. I've brought them in, placed them in my scene, and there's nothing on here that will make them react to anything in the scene. In fact, we can walk right through them if we were to play this game. What we can do then is to have these objects follow the laws of physics if we want. We can do this by adding on physics components, and these are under Component, Physics, and we can see we have a collection in here. Rigid body, character controllers, box, sphere, and capsule colliders, and so on. What these, and also the joints in the cloth, define are the ways that this object should react to physical forces and other objects in the scene when collided with. What these colliders, the joints, cloth, and forces allow us to do is to define how these objects react physically to other objects and collisions, such as characters running into them, explosions, things being knocked around on a floor, and so forth. We expect that when we bump into something in the real world, there's a good chance it might fall over, or we might recoil backwards, depending on the size, the mass of that other object. What the physics system lets us do then is put the properties of real physics onto our objects. There's two physics systems, as I mentioned, physics and 2D physics. There's our physics system, powered by PhysX, P-H-Y-S-X, from NVIDIA, and also Physics 2D. Our Physics 2D system is analogous to the 3D physics system, but made for our 2D objects, and all Physics 2D objects have a 2D after them. We see similar colliders, and these define where that object will collide with other objects. There's a box, circle, edge, and polygon collider. There's different joints, and again these have a 2D after them, made for attaching different objects together so that they have properties that we'd expect in physics systems, such as springs and wheels. We've also got different effectors, ways of affecting physics and having them bounce or form a platform, for example, and constant forces. Both of our physics systems have rigid bodies, and this will allow us to put in mass, drag, the possibility of gravity, and also interpolation and collision detection on these objects, so that they can judge not only how heavy they are, but how forces affect them. Keep in mind that the 3D physics components will only work on 3D objects, and the 2D physics components will only work on 2D objects, our sprites. The two of them will not interact, so we need two different physics systems depending on the objects we're dealing with. In the next videos, we'll explore the physics system and start to make these objects react physically correctly in our scene.